Let's try some more examples. A city planner claims that more than 40% of downtown parking spaces are occupied during weekday lunch hours. So this is going to be a proportion problem because your data was given to you in percent form and it's a categorical variable, a qualitative variable. The city planner is going around and saying occupied or not occupied as they're collecting their data. A random sample of 200 spaces found that 92 were occupied. So we're going to test the claim at an alpha of 0.05. So let's get our null hypothesis and our alternate hypothesis created and determine the tail of the test. So a city planner is claiming that more than 40% of downtown parking spaces are occupied. So that means currently we believe that 40% are occupied, so 0.40, and they believe that it's actually, the city planner thinks that more than 40%. So 40% is what we think is true right now. P equals 0.4 is our null hypothesis, 0.40. And the city planner is going to do a test to see if it's actually more than that. Whenever we have a more than, or if we think our alternate hypothesis is using a greater than symbol, this is going to be a right-tailed test. So now we have our hypothesis constructed. We believe the null hypothesis is 0.40 parking spots are occupied. We're going to test if it's actually more than that. So it's a right-tailed test. Let's get P, the standard deviation, and P hat. The population P that we're going to use will be the same as we identified in the null hypothesis, 0.40. To get the standard deviation, we're going to take our population proportion times 1 minus the population proportion divided by our sample size, which is 200, all of which is underneath the square root sign. So 0.4 times 1 minus 0.4 divided by 200, all underneath the square root. We'll use 0.3464. P hat is your sample proportion, so we need to go find our sample data, and we'll use those numbers. 92 spots were occupied out of the 200 in the sample, so that'll represent a sample proportion of 0.46. We now have everything we need to go get our z-score or our z-statistic and then turn that into a p-value. For population and sample proportions, to get our z-statistic or z-score, we take p hat minus the null hypothesis, 0.40, divided by the standard deviation, 0.46 minus 0.4 divided by 0.03464. And we will get a z-score or z-statistic of 1.7321. And now it's time for us to go get, from the spreadsheet, the left or right tail probability. We already identified that this is a right tail test, so I'm going to go to my spreadsheet, and once I successfully get the right tail, since this is a right tail test, my right tail is my p-value that we are going to use to decide if we're going to reject or fail to reject the null hypothesis. So let's go take our z-score, our z-statistic, and go get the right tail out of this, since it's a right tail test. So I'm going to type in the new z-score, 1.7321. It automatically updated the left tail because I already had the equals norm.s.dist, and I already clicked on the z-score. But I need the right tail. This is a right tail test. So to get your right tail, when you already know the left tail, we go equals 1 minus the left tail. So I'm going to jot down my right tail, 0.0142. 0.042. And now we're going to take our p-value and compare it against our alpha to decide if we're going to reject or fail to reject the null hypothesis. In this case, my p-value is smaller than my alpha. That's our alpha. This is our p-value. When your p-value is smaller and falls within the alpha range, it's smaller than the alpha, That is a statistically significant enough information for us to reject the null hypothesis in favor of the alternate hypothesis. So in this problem, we would reject that we believe that 40% of parking spots are occupied during weekday lunch hours in favor of believing we actually think it's more than 40%. Our p-value in our statistics was statistically significant enough to reject the null hypothesis in favor of the alternate hypothesis because the p-value was smaller than our alpha value.